Good morning, everyone. As per the UN Global Status Report in 2022, energy demand from buildings increased by around 4% from 2020, and that's the largest increase in the last decade. The built environment itself is responsible for 30% of our energy consumption, 39% of our CO2 emissions, and 40% of the material that we use. And 80% of the buildings that will exist in 2050 already exist today. This reinforces the importance of improving efficiencies of existing buildings, and hence the purpose of this session today to redefine smart buildings with AI-powered digital twins. In fact, digital twins can reduce a building's carbon emissions by 50%. Similarly, digital twins have been shown to improve operational and maintenance efficiency by 35%, increase human productivity by 20%, improve space utilization by 15%. By definition, a digital twin is a real-time digital representation of a physical asset that draws on the available data ecosystems and leverages advanced analytics, visualizations, and artificial intelligence to become the framework that connects the physical and digital infrastructure of a given asset. In this session, we will take a deep dive into the digital twin technology with advanced data analytics capabilities powered by artificial intelligence, offering valuable insights that can transform the way we manage our buildings. Topics tackled will address the swift detection of inefficiencies and faults, efficient asset management, and an overall reduction in energy and carbon intensity. During the session, we will also explore how AI-driven digital twin technology can address the challenges that are associated with building operations, leading to reduced energy consumption. We will also cover real-world examples of this technology, discussing the outcomes it can deliver, its potential to help organizations achieve their decarbonization objectives in our fight against climate change. Joining me today is a consortium of panelists with expertise spanning from digital solutions to building and analytics and innovation. And I would like to welcome them, starting with Faisal Shar. Faisal has been leading the Digital Twin Division at DAR since its inception in 2019. He has played an instrumental role in the development of Para. Outside his role as Digital Twin Lead, Faisal is a founding member of the DAR Innovation Group, a multidisciplinary team of designers and consultants who utilize their diverse backgrounds to craft innovation solutions that enhance our value offering, streamline our workflow, and solve design challenges. Faisal has Master of Engineering from MIT. Welcome, Faisal. We also have with us Yahya Matkour. Yahya is an architect and change maker with expertise at the intersection of design, technology, and research. As Director of Innovation at Perkins & Will, Yahya directs 5 research labs to advance the firm in the areas of human experience, research circularity, performance optimization, construction innovation, and physical digital experiences. Yahya is a book author and a public speaker. He currently sits on our group's Innovation Council, and most recently, he was a recipient of the 2021 Building Design and Construction 40 Under 40 Award. Yahya, welcome to the stage. We also have with us Amelia Fihan. Amelia is a senior analyst in the Verdantic Smart Buildings practice. Her current research agenda focuses on digital twins, IoT solutions in architecture, engineering, and construction software. Prior to joining Verdantics, Amelia worked as a facade engineer at Arup, where she gained experience in sustainable building design and construction. She holds a Master's of Engineering in Civil, Structural, and Environmental Engineering from Trinity College, Dublin. Amelia, welcome today. Our next speaker is Derek John Molassery. Derek is the Chief Operating Officer at CopperTree Analytics. He brings over a decade of expertise in data analytics, energy management, and decarbonization, with a master's degree in clean energy engineering from the University of British Columbia and an undergrad degree in electrical engineering. Derek has been instrumental in guiding CopperTree's clients to meet and exceed their energy and sustainability goals while improving building performance. Welcome, Derek. And last but not least is Shyam Sikar. Shyam is a seasoned smart building systems expert with over 9 years of engineering experience. As senior solutions strategist at DAR Digital Twin Venture Para, he specializes in digital transformation and optimization of the built environment. He's also experienced in energy optimization of commercial, residential, and critical buildings such as hospital, laboratories, data centers, and manufacturing facilities. Welcome, Shyam. Hi, everyone. What a great panelist. I'm going to start with just a very common question that I think the audience is all expecting from us. I did define what a digital twin is, but would like to see and hear it from you guys, each and every single one of you. How do you define, because I'm sure that potentially maybe each one will define it in a different way depending on their background and their area of expertise. But how do you define a digital twin?
I think the concept is very versatile. There are different applications and use cases for digital twins. So obviously there are different definitions out there. I'm not going to go for the long-winded definition because I'm going to let the other panelists contribute to it. But starting with the main part, it's a real-time digital representation of a physical asset or building that really simulates performance.
So at a personal level, I think every one of us is relying more and more on data, whether it's sleep habits or exercise patterns. And I think the idea of understanding performance as it relates to a physical object, in our case, we're physical human beings, but understanding how we could use this data to enhance our performance is really the idea behind the digital twin. So beyond the technical terms, what I would think of are 4 questions, which fundamentally we're all trying to answer. What has happened? What is happening now? What will happen in future? And what, if anything, would change? And within those 4 questions, you can start to think about like how digital twin can actually change how we do things.
Great, thank you. Yeah, so I would agree with my other 2 panelists. So I see a digital twin as a virtual representation of the real world, which uses real-time data and analytics to simulate it. And I think there's a lot of thoughts that digital twins can be very complex, but they can also be quite simple, and we're using some in everyday life that we may not even know. So I like to think of Google Maps, for instance. So if anyone used Google Maps to get to the venue here today, that has a 2D map replica of the real world. It uses real-time data from things like traffic conditions. It also brings in user data if there's hazards on the road. So it already has a 2D replica. It uses real-time data. And then it also uses AI and algorithms to recommend the best route to, let's say, get to a venue. So digital twins have woven themselves into our everyday life. Things like Google Maps, things like Fitbits on our wrists. And I think it's very easy to go to that kind of complex thing, but at its essence, it is that real-time virtual replica.
Thanks, Amelia. I'll just take it from where you stopped at. So you have a virtual representation of a real building, and there is flow of data happening between the 2. And that bidirectional flow of data is very important because it's not just all of the assets in the real world being represented in the virtual world. It's also how can we get that data in the virtual world and engage the user so that they can maximize the information that's there. So even if you take the example of traffic on the road, there is travel, people traveling, traffic, but it has to be an organized flow for it to make any sense for others in the mix. If it's not organized, then you sit in the traffic for a long time, you waste your time. Again, having data in itself is not as good. You need that information which you can then use to condense it in a form that's engaging to the user. So, Shyam?
Definitely, I agree with the other panelists. So, from my perspective, digital twin is the digital mirror image of a physical asset. So, when we call an asset, it's going to be always combined with design data, all the other metadata, even the location of an asset, and other real-time and operational practical data that's going to be combined with an asset. So this creates a rich data environment in which any application can sit on top of it. Let it be the advanced analytics, AI models, or different AR, VR applications which can sit on top of the digital twin platform, which will significantly improve the efficiency of the physical asset and capture the complete potential of the physical asset. Because right now, when we have a physical asset, right now it may not be used to its fullest potential, but by analyzing the entire asset in a digital format will help us to understand the places where the asset is not performing well at this moment, how well the performance of this asset could be improved.
Well, thank you so much for all of those great introductions and definitions to what digital twin is. But Amelia, I'm also very much interested in understanding a bit the history about digital twins. How did they emerge? How did they start integrating into the smart building market? And what were the factors that have actually influenced their introduction?
Thank you. Great. Yeah, so if we take it back to before the digital twin term was even coined, the actual concept is thought to have come from NASA. So it was from, in 1970, the Apollo 13 space mission. So if anyone can remember that or saw it on TV, the oxygen tanks exploded on that aircraft, that spacecraft, and the NASA scientists had to think, how do we solve this problem of this failing asset thousands of miles away in space? And so what they did, they turned to digital twins. So we didn't call them digital twins at the time. They were called sort of like complex simulations. But they carried out simulations of different operating conditions to help land that spacecraft safely. So that's where we thought the first sort of digital twin concept came from. Over the years, it's evolved, and the actual terminology was defined by Dr. Michael Greaves in the early 2000s, and that was to do with product lifecycle management. So he said a digital twin had to have a physical part, a digital counterpart, and a connection between the two, which you've kind of spoken to. And then over the years, we've seen it move through the automotive industry with the likes of things like Tesla. We've seen it in healthcare. We've seen it in manufacturing industries. And it's entered the real estate sector through three different elements. So it came through IoT. So with the adoption of IoT, with sensors and devices, building managers now had access to real-time data. And they wanted to, what more can I do with this real-time data now that I have all of this? So what simulations can I do? What further analytics can I do? So digital twins came through IoT. We also saw them come through BMS, as well as the IoT, and through CAD and BIM. So in design and construction, engineers were building out their BIM models, and this data was being lost in the handover from design to operations. And so this left a lot of people thinking, how can we further utilize that BIM data? So that led people to think, okay, I'll apply some real-time data to it. I'll look into developing out that digital twin. And then we also saw it come through at the equipment level. So before a full building twin was thought of, a lot of building technology vendors thought, how can I optimize one single critical asset in my building? So that was around heating, chillers, that sort of equipment. So we did see it come through those three sort of prongs. So the IoT, the CAD, and the BIM, and also the equipment level.
So Faisal, Amelia did walk us through how we got to the technology, but from your perspective, why do you think we need AI-powered digital twin, and what are the challenges that you're facing every day with the digital twin?
Yeah, so I think it's three main challenges. The very first one is data management. So in any facility, and the more complex it gets, this becomes more apparent, operators rely on a very, very, very wide array of systems, like in an airport, and you have different stakeholders. And just dealing with that amount of data can be very overwhelming. And then these systems are fragmented, so you have data silos as well. So really understanding the data, analyzing the data can be very, very difficult. And what a digital twin does is it acquires data from all these systems, put them in one place in a unified platform so that they can take better decisions. So that's really the first benefit. Second thing is prediction. So digital twins are a decision-making tool which allows operators to run different simulations, what-if scenarios on the digital twins to really remove the guesswork out of what they're doing. So for example, if they want to simulate what kind of impact increasing the set point in an airport would have on passenger experience, on thermal comfort, they can do that with a digital twin before doing it in the real world. That's the second benefit. The third one, and that's arguably the most important one, is there was a recent number that came out of the WGBC's research that 80% of the buildings that will be standing in 2050 exist today and are being used today. And so these buildings need to be decarbonized, and if we just focus on new builds, then we're completely missing the mark when it comes to reducing emissions. So the idea is, how do you come up with a carbon reduction strategy for these existing buildings? And to do that, you need to analyze the data that these buildings produce to really understand the carbon reduction potential of each measure. So if you switch the lights from incandescent to LED, would that have a bigger impact on emissions than upgrading HVAC components, for example? So really having a digital twin, being able to run these different operational scenarios helps you come up with the right carbon reduction strategy.
Thank you. So Faisal has given examples of strategies that we look at. And typically what our clients ask for is real turn targets. And how do you see the use of the AI generate such real turn targets in the way that we operate our buildings and make them more efficient?
Faisal clearly explained one of the biggest challenges that we have at the digital twin platform, which is the silo data system. So once the data systems are integrated into a common data environment, now we have to really correlate this data and connect it with an asset. So this is where the two persons or two different skill sets work hand in hand. So one person who understands the core operation of an asset or a building, and another person who can completely handle this data and use the right AI model to transform this data into a targets. So let's take a simple example of an air handling unit. So it has got a zone temperature, a static pressure sensor, set points, and the supply fan and the cooling coil valve. So these entities provide a data, and these data have to be carefully evaluated. They have to be correlated, and these data will be used as a training set in the right AI model to generate the real-time consumption target. So now, when the real-time consumption target is going to be generated, we can compare it with the actual consumption. And if there is going to be a gap, then again this gap has to be validated, because we need to be for sure that the gap could be addressed with the right recommendations, and there are going to be different sort of recommendation that needs to be taken in order to eliminate this gap. So once the gap is carefully analyzed and filtered through a clear validation process, and the right recommendations will be applied on top of it. So let it be the increasing the supply temperature set point, or reducing the static pressure set point, or reducing the operating hour of the asset itself. And the most interesting part is, when the data that comes from an asset, when it is going to be correlated with the other external data such as occupancy or weather conditions, through which the complete behavior and operation pattern of the asset can be exactly mimicked, through which we can generate the clear real-time targets.
Great, and building on this, Derek, I want to look a bit closer at examples, and specifically at some challenges that you might have encountered in the practical implementation of building data analytics and digital twin. If you can share with us some examples and with the audience, that would be great.
Lots of examples. But maybe I'll start with the technical one, and then there are organizational challenges too, because it's not always the technical problem that you have to address when it comes to digital twins. On the technical side, I think Faisal referred to it. Sham, you kind of expanded on it. But let's talk about this. in a building, you have different systems. You have your heating, ventilation, air conditioning system. Amelia, you talked to IAQ sensors, a lot of investments by building owners on installing IAQ sensors. You have access control systems. You have fire and safety systems. They're all there. Investment has gone in, but those systems don't necessarily always talk to each other. And that's the challenge. Now, a very good digital twin solution and an analytics solution will be able to collect the data from all of these different systems, bring it together so that it's meaningful. That's huge in buildings. Otherwise, there's money going in, and yes, it's pretty, it looks great, but the real use case can only be untapped when all of that data becomes good information for the end user. And it could be multiple stakeholders. It could be the building owner, it could be the occupant, it could be staff that's using the space for whatever use cases they have. Everyone has to benefit from it. And maybe I'll touch on an organizational challenge as well. You can invest in a digital twin, you can put money into it, and that's good because it's good technology, but you've also got to look at the internal operation and see if the new system that's being installed aligns with the operational processes that are in place. Technology is great, but at the end of the day, you've got to make sure that the people and the culture within the organization is aligned to what the technology needs to do. So the investment has to be accompanied by organizational workflow changes, mindset changes. Hey, sustainability is key, but for sustainability to work, to walk the talk, you've got to make some changes in the way you operate the building.
So on that point specifically, Faisal, on the operational challenges and implementing digital twins for aligning with operational targets. The digital twin technology is integrated within our Dar Cairo headquarters. So what are the challenges and the experiences that you can share with us from that specific example?
So let me expand on that building a bit. It's a LEED, so people from Dar would be familiar with that, but it's a LEED Gold certified building in Cairo, 48,000 meters squared, so it's a really big building. It was really efficient, but we felt like there was room for improvement in that building, so we deployed Para over there. And the biggest challenge by far, going back to what Derek said, is organizational change. Just really understanding how the operators deal with certain problems in the building, the different workflows they have, and making sure the technology aligns with these workflows. So that's really where we spend time. And that helps us define the use cases, because if you acquire data from the different systems and you have the technology, if it's not delivering value, then we're not going to see an ROI. So that's really the important thing. So that's what we focus on over there.
Great. ROI, I think that's the key word to everyone. So artificial intelligence, Shyam, and that question goes to you. It did already demonstrate that it's capable to address the sustainability challenges that we're facing today. But what is the unique value that we get from combining artificial intelligence with digital twin, and what does this combination bring to the table specifically?
So as other panelists have already highlighted, digital twin is going to be a combination of the data source. It's going to be holding the design data, real-time operational data, and also the maintenance records and all the metadata associated with the building and each and every assets within a building. One of the unique value proposition digital twin is going to be providing is the spatial intelligence. Let's say, for an example, I have an issue with one of the asset, and it may be an issue with the asset, but it may not be an issue with the asset, because asset, it's just not a standalone entity. It's going to be served by, it is also going to be serving to multiple other assets. So establishing the relationship between the entire ecosystem of an asset plays a vital role in identifying the root cause for what the problem is. In a simple air distribution network, so we may have a dedicated outside air unit, which is feeding the air to the air handling unit, and then air handling unit is going to be feeding air to the VAVs. So that's the entire ecosystem. If there is going to be any fault that is going to be detected at one particular level of an asset, it has to be automatically routed to the entire ecosystem. The entire ecosystem has to be analyzed to understand where the problem is exactly happened. So it eventually helps us to take a better decision and understand the root cause analysis where the problem actually existed and how it can be easily eliminated in order to improve the efficiency of the entire ecosystem.
Great. So on efficiency of ecosystems, Faisal, you had mentioned earlier that 80% of the buildings that will be present in 2050 are already present today. So that means that we need to invest heavily in existing buildings and retrofitting existing buildings. And also, the built environment will keep on expanding and expanding to 2050, 2060, and it's expected to even triple. So what are the different approaches that you see to future-proofing the new buildings and also the existing buildings?
Yeah, so I'll touch on future-proofing because we hear it quite often now. So future-proofing is basically an assessment process that ensures that you can maximize your whole life value of a building and be prepared for unpredictable ongoing change, whatever can happen. So when it comes to digital twins, what that really means is taking measures during the design phase if it's a new building, or coming up with a retrofit strategy if it's an existing building, to make sure your infrastructure has the capacity to accommodate a digital twin or new technologies. So essentially, we're future-proofing against three different things. The first one is tech disruption. So technology keeps evolving at a very, very rapid pace. What was state-of-the-art in 2015 is not state-of-the-art today in terms of technology. So how do you make sure your buildings keep up with these changes? The second thing is future-proofing against ESG sustainability regulations. So the landscape is evolving again at a very rapid pace. Jurisdictions are passing new legislations, and this ensures that building owners, operators can report on environmental metrics and stay ahead of policymakers, which is also important. And then the third one is future-proofing against the energy performance gap, which is a gap we see in building between actual energy consumption in the operation phase and predicted energy consumption in design. And that gap tends to widen as the building ages. So with a digital twin, you're able to measure that gap, conduct a root cause analysis, really understand what's happening, and make sure you close that gap in buildings.
And the talk has been great as to the energy consumption and the energy efficiency measures. But buildings' footprint and their environmental impact is also beyond just the energy consumption, the LED lighting, the HVAC systems. So Derek, how do you see that we can measure the overall success of the AI-driven digital twin technology in reducing the overall environmental impact of a building? And what examples can you share with us?
Well, the obvious one is energy, but energy is directly related to emissions, and we all know that. That's why we're here. When you talk about emissions in a building, just to 50,000 foot level view, right? You have energy being consumed, translated to emissions, because any source of energy, depending on what source it is, it's got an emissions factor associated with it. And so you have energy translated to the greenhouse gas intensity for the building. I think someone referred to performance gap in buildings, where you construct a building with the desire that it's going to model and work this way. But in the real world, buildings drift away from that desired state. And that is true for any and every building out there. It's not a unique thing. It's not a unique problem. It's a very common problem. So GHGI, greenhouse gas intensity, that's a good way to measure the environmental impact. Two other things that I could perhaps touch on. One is water. It's interesting, when we are in the business of talking about carbon, oftentimes you forget water. But water is as important in the conversation as energy and emissions. So tracking water usage in buildings and making sure that we are always saving it wherever we can. And with AI, you have the use case of you're not just tracking it in terms of consumption, you're also coming up with ways to improve the usage of water. And that's important. And maybe a third one, a real life example. I'm currently working with our team on a project for a client where they have this system in place where employees come into the office, every day breakfast is served. It's all good, right? Great employee productivity. Prior to COVID, this was working just fine. As soon as COVID hit and after, you have a use case where the occupancy in the building is different on different days. So how much food do you prepare for your employees? It changes. It's a moving target. And so again, with AI, you can predict based on patterns in the past, based on schedules in terms of meeting calendars, etc. You can predict how many people are going to be in the office and then make food just enough for the people who are going to be there. So reducing solid waste, food waste, different types of waste is as important in the equation as emissions and energy.
Thank you. Amelia, I don't want to put you on the spot, but I think that as a building analyst, we'd all love to hear your perception on this and if there's any additional feedback that you'd like to add.
Yeah, so Derek, you made some great points. I'm going to take it back to my career before I was a building analyst. So I actually worked as an engineer on a lot of construction sites. And as you were saying at the end around materials and minimizing resource wastage, a lot of the time on construction sites, I saw a lot of rework activities. So, you know, you've put up your facades, they need to be taken down, a lot of material wastage, and digital twins can really help minimize this. You can trial things like your assembly process in that virtual environment, and you're minimizing the need to carry out rework activities on site, you're minimizing the need to waste materials, and that also helps with the environmental kind of impact reduction. And then moving more to kind of the building operations side of things, I've been talking to a lot of real estate developers and building owners, and maybe one of the more indirect ways that digital twins can help minimize environmental impact is around kind of space optimization. So obviously, we've seen with the kind of hybrid working, different sort of occupancy patterns and things like that. But a digital twin can allow you to carry out those space planning activities, reconfigure your existing workspaces so that you're optimizing it. And I was actually speaking to a building owner who managed to increase their space optimization by 40%. So they actually managed to get in an additional 40% of their employees by intelligently reconfiguring the space in the digital twin. And that mitigated the need to build another office, again, mitigating the need for further environmental impact from the building. So those are some other sort of examples.
Great examples. So typically on and that's back to you, Derek, on a net zero roadmap, we always start with the energy efficiency. And there were examples that were shared by the panelists, from the lighting to the HVAC and to the materials part of the whole life carbon approach and so on. But there's that last bit that's also very important, which will get us to net zero, which is renewable energy. So how can AI-driven digital twin technology complement and optimize the integration of renewable energy sources within our buildings?
That's a great question, because buildings, there is an ecosystem of buildings, but buildings on its own is not the full city. Cities are made by buildings, plus there are grids, there are other overlays in place, and all of these different systems need to talk with each other. So to the point on renewable energy, I would start with number one, the uncertainty around renewable energy in terms of how much energy, kilowatt hours, are you going to get out of the panel today or the wind turbine today. You don't necessarily know that depending on what changes there are happening on the weather situation. So with AI, you have a record of what's happened in the past. You analyze that. You have forecast weather data that's coming to you, and you can predict how many kilowatt hours of energy is going to be generated. Now, that's great on the utility side because you know what's coming, what's available in terms of energy. What's also important is what's happening within the building, because within the building, there are different use cases, there are different demands, and so you can model and understand what is the energy consumption within the building going to be. So you have modeling being done on the renewable side in terms of how much is going to be generated, modeling being done within the building in terms of how much consumption is going to happen. What does that relate to? Well, that takes us directly to load balancing, because now you can do dynamic load balancing, and you can say, well, when there is renewable energy available here, well, we can use that in the grid, and that can be used to provide energy for the building, and that helps with the entire conversation around grid resiliency and ensuring that the emissions overall from what we're doing is reduced. So I like the balance in that it's not just on the building side, it's also on the the generation side, and you bring it all together with the use of digital twins.
So there is always a thought process here. So if I use a renewable energy, my building will be completely a net zero, right? So, but if the building is actually wasting energy, even after shifting from the traditional process towards a renewable energy, still the energy is being wasted. So the digital twin will help to identify this energy wastage. So the first step is to identify the energy waste, completely eliminate the energy waste, and then transitioning towards renewable energy will be the best approach, because even to transition towards the renewable energy, there is going to be enough capital expenditure that's going to be involved in it. So I don't want to be spending more on a capital expenditure, whereas my building really needs very less energy. So the key is to identify the energy wastage, eliminate it, and then transitioning towards the renewable energy.
Yahya, over to you now. So if we look just beyond the building's boundary, right? How can we use potentially digital twins if we are to integrate this in transforming our cities to smart cities, into having more sustainable, more resilient urban ecosystems? So how do you see the role of digital twin at that scale?
So at the city scale, you're essentially thinking about a lot of different systems very similar to how you think about in a building. So you're looking at traffic management, you're looking at waste systems, you're looking at energy, you're also looking at the connections between buildings together. I think cities have a lot of potential when they understand how the cities operates through a digital twin to be able to optimize the systems within a city, and then allow those systems to understand the dependencies between them. So for example, if you're looking at traffic management, this has a connection to air pollution. It also has a connection to noise management. It also has a connection to unemployment in a city. So understanding how all these systems affect each other, how can you simulate, what a future position might be. If you want to reduce air pollution, you might want to start to think about how you might reduce that through traffic management and simulate this. And these are all the areas for optimizing systems within a city. Barcelona, if you look at this city as an example, I think they're doing some amazing work with digital twins right now. They've looked at this concept of a 15-minute city, which is the idea of being able to walk or bike to all the amenities that one might need to have, whether it's hospitals, cultural things, your work, leisure. And this ability to do that is only possible where you actually really understand all of the assets within the city. So the idea is not just to understand that so that you can provide those assets in the right locations and within the right communities so it's very distributed, but also from an equity perspective, understand what are the populations that actually don't have access to that and how can you serve them better. There's a lot of work that can be done within cities to equitably manage the resources and understand how to manipulate certain systems together. I would say also in construction, when you're starting to think about a new development in the city, what is the effect of that particular new development on the ecosystem around it? Again, in terms of traffic, in terms of understanding how people move through the space, what kind of pressures are on certain infrastructures within the city. These are all things that can be simulated because you understand, a certain development comes with a certain amount of population coming and a certain usage. So there's a lot of ways where you really can benefit from the idea of having data and the idea of understanding the effects of this data on how can you forecast the future. And from there, help us in decision making.
So Faisal, we've heard of the great values of digital twin in buildings and also cities. What are the unique benefits that digital twin offer beyond just the standard energy management software platform or the IoT platforms, for instance?
There are many things apart from energy management. So there's less on the efficiency side, making sure buildings are resilient. That's another important one, especially if we look at hospitals, healthcare facilities, right? They need to be resilient, an asset can't go down. And they're designed with redundancy in mind, but making sure they're operated the right way. You understand what's going on with the systems. They're maintained proactively instead of reactively so that you can deal with faults before they turn into failures. Is really important for these buildings to last. And these buildings are meant to last for long stretches of time. I think that's an important one. Another thing is monitoring indoor conditions is really important. So looking at comfort parameters, air quality, temperature, that can all make a difference, especially in offices right now. So these are other things we can do outside of efficiency energy.
Now, there's a question that's always, I'm sure you always hear it from all of your clients, that there's great value to digital twins, but how much does it cost? Like, what's the level of investment that we're looking at? Is it very high? How can you mitigate it? How do we see it moving forward? Amelia, do you have insights in sharing how this level of investment will actually be advanced as we move forward in the digital twin space?
Yes, so I think there is definitely some basis to the belief that it is a high investment to implement a digital twin. It's obviously very project dependent. It depends on the scale as well, and where you are in your digitization journey. So let's say you're at the start, you'll have the cost to deploy sensors, devices, cost to build out the IoT networks to get that real-time data, cost to purchase the software, cost to train people to use the software or hire an external service provider. But I think the really important thing is to consider how are you contextualizing those costs. So what are the immediate savings? What are the long-term savings? So in terms of some of the savings that we've seen around a 15% to 20% operational cost savings, and that's driven by energy cost savings that the digital twin has helped driven energy efficiency. We've also seen it help drive things like predictive maintenance, so less requirement to continually be in a reactive maintenance mode, so purchasing of the components and things like that for the equipment. So I think it's really important that, and as I kind of spoke about that rework example earlier as well, rework in the construction phase can cost around 5% of total project costs. So when you start seeing that there's savings in the operational phase, there's savings in the design phases, you can start building out the business case for a digital twin. And I think it's also about, you don't have to tackle everything at once. You can start small, you can scale. So I was talking to a building real estate developer and owner, and they have started with a digital twin for 2 of their buildings. And over the past 2 years, they've actually expanded to 60% of their commercial building portfolio. So what they found with just implementing in those 2 first buildings was that they were able to kind of prove that business case. They started with energy management as the major use case, and now they've built out to 60% of their portfolio. They've incorporated things like the occupant comfort, maintenance, as well as just that energy use case. So I think that really helps with building out the business case and showing that ROI is generated over the lifespan of the building.
Yeah, just adding to what Amelia said, just one thing. I think digital twins demonstrate more value in complex environments. So the more complex the environment is, the more value it can deliver, such as airports. The challenge there is you have many different stakeholders, the more complex the environment is, such as airports, and just getting them to the table, getting them aligned, trying to understand their objectives can be a challenge. But if you do that and you come up with the right use cases, then the investment would make sense.
Great. Yahya, you've mentioned serving people, serving population, right? And just yesterday, we launched our new group brand, Sidara, that had 3 pillars to it. Technology, sustainability, obviously we've been talking about this quite deeply today, and livability. So from your perspective, how do you see on the livability pillar, digital twins capable to enhance the human experience in our built environment?
So the human experience starts with humans, right? So I think the very first thing to start thinking about is how people move through space, how people interact with space, understanding with sensors data or computer vision what type of interaction is happening, and are we designing the spaces in the way that they're actually being used, or is it more of a vision that then gets proven otherwise? I think understanding how people occupy spaces is at the center of that. And then you start layering in different aspects that can tell you about well-being. So when you start to think about well-being, think about thermal comfort, for example. So the environmental data that you can get from, several data points around, temperature, humidity, radiation, or the visual comfort aspects around, light, daylight, intensity, and color, or the perhaps acoustic comfort around noise and intensity of that noise and where the location is, but also indoor air quality and particle matters. Like all these things, when you start to overlay them on top of each other, it starts to give you an idea of what kind of comfort do you have in space, and that starts to think about, or starts to tell you about the human experience within that space. So that's from an environmental exposure perspective, or a human comfort perspective. When you start to understand not just these data points and mapping them out on the space, but also how people interact with different spaces within a certain office or a certain building, you can then start to make decisions around how to enhance, whether it's the noise level reduction or understanding how to manipulate glare in a certain way. But you only are able to do that when you have the evidence and the data. So that is a part of understanding really what is the effect of what we're designing on humans and what is that perception. So that's on one side, which relates to how people are occupying space and how do they experience it. And the more data and understanding that you actually have on that, the more you're able to enable decisions that affect that human experience in a better way.
Great points. I want to touch on an example from a project that we're working on right now. Classic situation, right? Almost every time when you have people in the building, carbon dioxide level goes up. What you need to do is bring outdoor air in. That's how it works, almost every time. This year in Montreal, we're based out of Vancouver. We have clients all through North America. We have a client in Montreal, and there was forest fires happening in Montreal this year. And because of the forest fire, you have particulate matter 2.5 and the concentration of these PM 2.5 in the atmosphere at a very high level. And so the last thing you want to do when you have PM 2.5 levels exceeding your threshold is bring all of that air right into the building. So how we are designing the building is to do exactly that. But you shouldn't do that, because now you have a very unique case where you have to look at not just the indoor data, not just your equipment data, you also have to look at the environmental data. And talking to your point, Yahya, about making sure that our occupants feel safe and comfortable within the buildings, that's such a key thing. And this is when AI and digital twin, you can tap into all of these different ecosystems, tap into all of these different data sources, bring it all together and tell our clients, our occupants, our tenants the story that, hey, when you have DT, digital twin-based technologies in play, you can be sure that the space inside is safe and it's comfortable.
Carbon dioxide, I mean, that reminded me of one thing I wanted to add. People strive when they have control. And I think the understanding of, when you're in this meeting space and it's a closed room and it's, it's an hour in, you've got the carbon dioxide levels rising up and you're essentially in a place where you have brain fog. Enabling people to have control over that actually is an amazing thing that would enable a much better human experience. So from one side, you could either automate systems. So when there's a certain threshold that's come up, you can automate ventilation systems or operational of windows and all that, so that you can reduce these levels. But you can also very simply, if there's a dashboard in that meeting, say, take 5 minutes break. It is a time where you can actually have agency over your environment. You can open up, open a door, and within like 2 minutes, these levels go down again. So there are very simple things to be done, but can be only enabled by understanding this. And how do you visualize this data to actually show people their agency over the space that they have? Also is a great way for people to like get, to have a better experience.
And that's great. And I'm going to build on those real case studies that you've shared with us about the importance of AI in digital twin. And I want to close this session before I hand it over to the audience with just a common question for everyone to hear all of your thoughts. Why do each and every single one of you really think that AI in digital twin is the future? And what are the enhancements that we need to do to our communities to promote sustainability, resiliency, well-being, the human experience, and everything else?
I think I'll focus a bit more on AI than digital twins, and this is more of a looking at the macro trends of the world. I think there's a lot of talk about the great demographic decline, right? So less people working, but populations are going up, urbanization is still high, so cities are growing it, we're seeing it in the Middle East, and people need to operate and take care of these cities. The challenge is maybe we don't have enough people, right? They're struggling to hire. So AI would allow us to do more with less, and I think it can be really powerful if it's leveraged the right way.
I mean, for closing, there is one thing I wanted to mention, which was I think architects and engineers should strive to be there for our clients for the life cycle of the building and not just at the start. And I think understanding that digital twins and AI can enable us to do that, where we're there for the experience. It's not that designers are handing in and finishing their projects when our clients and the owners and the operators are starting their thing. We can continue to be partners together by understanding this data, analyzing it, and making sure that we're in a space where the organizations are changing and the patterns of work are changing. We are in a place to understand that change and fine-tune the buildings and the design, every year, every 2 years. And being proactive about that allows us to be way more sustainable because we're not waiting for that gap between how people use space and how the space is to widen, and you're not waiting for that big moment where suddenly, someone decides a big renovation needs to happen. We can continuously fine-tune, and digital twins will allow us to do that.
Great, thanks. So I think the real kind of beauty of AI and the future of digital twins is about finding relationships between really sort of diverse data sets and kind of finding those synergies between domains. So I think the future will be new use cases that maybe we haven't even thought of today, but bringing those all in and finding different relationships between things like that. So we're starting to see use cases around climate risk, building resiliency come to the fore. There was a Air Force base in the US who was hit by Hurricane Michael in 2018. They decided to build out a digital twin to simulate hurricane scenarios so that they're prepared to sort of climate change and potential natural disasters. So I think building that digital twin now, it can help prepare for all those future cases that we might not even think of today, but that AI can use machine learning to find those different relationships. So I think that's where it will go. That's kind of the future.
Thanks, Amelia. I'd like to close by saying there are no smart cities, which is our dream. We want smart cities, smarter cities. And there's no smart cities without smart communities. And so we can talk all we want to talk about technology, which is a very crucial piece, and we should, and we must, and we should have technologies that continually evolve. But at the same time, we must make sure that at a community level, there is engagement with digital twin technologies. This could be education, this could be training programs. We should make sure that everyone can access the benefits that come from AI and digital twin technologies, and that should be equitable. And I think that's a big piece to what we are trying to do with digital twins.
Like all of us here, so we use our past experience and present experience to decide the way how we want to act in future. Similar to that, every building has got its unique experience. The experience starts at the design stage of the building, and then the real-time operational experience of the building. And just we are talking about digital twin of one building. Let's put together thousands of digital twin together. Now that's a rich and wealth of experience of each and every individual building's unique experience combined together. So now AI technology can act on top of this to transform this entire building into the sustainable and energy efficient phases. And also, based on the good experience that is coming from each and every building, the AI models can create a futuristic design which can be sustainable and energy efficient from day one when it is built. Thank you.
Thank you for such a great panel. We've taken the full hour just with this discussion, and with the, yeah, I'm gonna hand it now to the audience for any questions you might have. We'll start with Dr.
Thank you all for a great discussion. I want to share an experience and then I have a question. The experience is, in our Cairo office, we had a gas leakage from an industry a few kilometers away from our office, and it affected the air quality. And having, I worked with Faisal closely on that, and having digital twin installed in our office helped us to, tackle the situation in a very efficient manner. We closed the fresh air intake, and the sensors, we got the readings, and had the levels gone up beyond a certain threshold, we would have asked the employees and the staff to evacuate. But luckily, the situation was contained, and we informed the authorities and the civil defense, and it was taken care of. So I would strongly encourage everyone really to use the digital twin because it's a great application. My question is, while I understand the focus of this seminar is on buildings, and you touched on cities and the hurricane, I feel that digital twin, when the application of the digital twin and the AI when it comes to the city level and the infrastructure in general is a bit behind. It's easier to do it in a building in a confined space, whereas for the city level, it's more diverse, it's more wide, and applications are more complicated probably. But one of our clients here, actually Dubai municipality, asked us about how can we simulate like flood events, how can we evacuate people, how can we have early warning system, decision support systems, how can the computers talk to each other, modeling, complex modeling, how can they talk to each other, predict events, and then send, for example, text messages to all the staff to evacuate a certain area or certain building or whatever. I have a feeling the application of the digital twin is a bit lagging behind when it comes to these sort of applications. So I was wondering, what are your thoughts on this and how we can work together to expedite this?
Thank you. Anyone would like to answer the infrastructure part of digital twin integration? Some examples, maybe? I'm sure you do have quite a few.
So during this panel discussion, we concentrated and focused more about digital twin within a building. So when a digital twin is going to be constructed, it needs to be constructed in such a scalable manner. So it can be extended from a building to a roads, to a ports, and to the entire smart city. So that's the most important thing. Of course, we are definitely not there yet, but in future, when we are going to be building the digital twin, we have to be very conscious about scalability of this, so it can fit any purpose and act on any city scale, or like even at the country level as well. That's my thought on it.
Want to go first? Great question. I just want to say one word, which is compatibility. Within buildings, you have multiple systems. For them to talk, they need to be compatible with each other. The same compatibility has to come through when you talk about many buildings at a city level, different systems. That compatibility piece is so important, because if you don't have that, now you have a situation like a natural disaster, and you can have really smart systems, but they ain't talking to each other, and you're not getting the value out of it. So compatibility is as important as scalability.
Great. So the example that you spoke about, it reminded me of a initiative that's currently being run by the EU Commission. So it's called Destination Earth. and their plan is to create a digital twin replica of the whole world by 2030. And they're looking at the things that you mentioned, so like flood defenses. It's kind of like sort of natural disasters. How does that interact with human activity? And some of the things that they've spoken about is the openness of data. So ensuring that data is open, systems are open, so that they can access all this data will really help with that program. But yes, it's still very early stages, but I think that's where we'll see it going to, not only that city level, but that's the whole kind of world level. Yeah.
That's a very, very interesting example. Amelia, thank you. Are there any other questions? Catherine.
I don't know if we've got time for, I've got two questions, but okay, first question, and it goes very much to Yahia, your observations around the fact that we need to look at the experience of people. And so thinking about that and thinking about the fact that we all have digital footprints, what are your thoughts on the fact that we can bring in perhaps social media data and integrate that in terms of how that might inform the sort of dynamism on the space? Clearly there are privacy issues, but I mean that, if you think about it, would be one of the obvious directions to go in.
This reminds me of an example of, I think it was research used in the city around understanding Twitter feeds, parsing the data, also looking at specific, geographical locations where photos are being taken, they're posted on Snapchat or Instagram, to tell others in the city what are the happenings. So if I'm a newcomer in the city, or I'm looking forward to get to be more social today, and I want to understand what is up and coming in any city at any point of time, I came back to that idea of real time. There are systems out there that can take the feeds and understand whether there's a particular conversation that's happening around some event within the city, or there's particular photos and moments that are being captured, and that would allow people to understand more about what are these events that they might want to go to, or where some of those things that might be interested in. So I think this idea of understanding how people understand space more in a geographical geospatial data, and yeah, you can get all sorts of things from social media, and it's all open.
You had a second question? Yeah.
So the second question, thank you, and I agree. I think there are tools that allow you to track the social media of the people occupying your building, so you can be creating serendipitous moments that can improve the experience. But so my second question is the circular economy. So clearly a digital twin stores a lot of information about that building, including the materials, quantities, and so on. And so why are we not hearing more about digital twins being able to inform materials, but availability for when there is a refurbishment, and therefore then it integrates with other models? You can then look to see what you can do with materials exchange. So just some thoughts about how we can kind of go tackle the holy grail of the circular economy as well. Amelia, you're kind of itching.
I think because it's quite a nascent space, we haven't seen as many sort of retrofit refurbishment examples. But there's actually one coming out of a university in Scotland right now. They're looking at different refurbishment strategies for their whole campus redevelopment for energy efficiency. So their plan is to meet this 2030 net zero target. And right now they're using the digital twin to simulate different energy systems that they could bring in, different renewable energy sources. If they bring in solar, if they bring in wind, how will that impact? So they are actually currently using that digital twin across 3 of the buildings in their campus, with plans to expand more. And I think that will inform exactly, like the equipment they decide to retrofit. And I think when we start getting it into the kind of earlier life stages in the design and the construction, that familiarity of digital twins with engineers, with architects, will help them when they're coming in at the retrofit, the refurbishment stage, with being familiar with this technology, being able to use it to simulate those what-if scenarios. So like, what if I brought in renewable energy into my building? How would that, how would my building react? What would the performance optimization be? So yeah, so it's nascent, but it's happening. Yeah.
I want to add to that. When you start thinking about designing for disassembly, this is where you can start thinking about buildings as material banks. So right now in Vancouver, we're moving offices, Perkins and Will. One of the things that relate to digital twinning is understanding all of the assets that we currently have, furniture, desks, spaces, and all that. And what kind of things can you take from one office to the other? That needs a data management, that needs an understanding and, a whole cataloging of every single piece that exists in the office and understanding what's the future life cycle of that piece might be. So you can upcycle things. You can upcycle, certain desks and cut them in certain ways to like do shelves in another place. But understanding what exists first is important, and you will only understand that when you have like a digital catalog of it, which is again part of digital twinning. And it allows you to be able to use one thing to the other and like reduce waste. So that's in sort of like the retrofitting space. But I would also say like there's a whole move towards a design to fabrication continuum in a more seamless way. So this, speaking to what you're speaking about, Amelia, is the idea that we're currently building 3D models to the highest degree of information available. However, our construction industry is only taking this back to printed 2D sheets so that then they're able to bring it back again into like a 3D physical object. So there is a downgrade in information only to like actually build another 3D physical object later. With digital fabrication, there is a way to essentially connect between design to manufacturing models directly, and that needs a digital twin. So to understand, a digital asset that you're designing, it's a building or a car or anything, understanding how it's going to be in future and what are the pieces that are needed to be together and how can you cut them, manufacture them, assemble them in a direct way so that you're reducing waste, you're reducing things on construction sites. These are all things that would allow us to be way better in circular economy. And, it's digital twin is a big part of it.
As Yah has already mentioned, so the data for the digital twin is already available. The material and different types of material that's used in the building, that's already available. And now when this particular material is subjected to a real-time environment, how it is actually acting, whether the material that has been used for construction, is it really giving the results that it was supposed to give? Was it like simulated, the results are expected as per the way it was simulated? So if there is going to be any deviations, these data are going to be captured over the period of time when the material is subjected to the real-time applications. And now, and Faisal also mentioned about the what-if scenario simulation. If I had to replace this particular material with the different materials, so now I have all the other independent data that is already available, and that's correlated to the specific material. All I need to do is like replace this material with the material which I'm thinking is going to be giving me an efficiency, like better efficiency. So when I replace it, so it's going to be like kind of a plug and play of different materials using the what-if scenario simulations in the digital twin model and the technology of AI, which will help us to reach to the better decision on which materials has to be replaced, how it has to be redesigned, so that the entire efficiency of the building ecosystem could be improvised.
Well, thank you. Thank you so much, everyone. And just for the sake of time, we're going to have to wrap up. This was a great, great session. Thank you to each and every single one of you. Thank you for the audience, for the questions that you've asked, the great questions. And I want to just say that all of our panelists are around. If you do have questions, they are around to answer them. Thank you again. Thank you for the great insights. And thank you for the great topic and all of the great examples. Thank you so much.